Hey guys, welcome to our lesson tonight where we're going to be graphing quadratic functions in standard form. Now today during class we graphed quadratic functions in vertex form, which we could use transformations and translations to help us find the vertex and axis of symmetry. Unfortunately, when an equation is in standard form, it's much more difficult just to tell what's happened to the graph based on the equation. Luckily, we do have some formulas that help us find key characteristics. Okay, so your learning target is I can sketch the graph of a quadratic function in standard form. Okay, standard form of a quadratic function is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. So first of all, a tells us a lot about our graph. It tells us whether it opens up or down. So if a is positive, greater than 0, the graph opens up, which would make our vertex a minimum, the lowest point on the graph. If a is less than 0, it's negative. Our graph opens down, which makes our vertex a maximum. Now, on these two pictures, you see I have the terms decreasing and increasing where the graph is doing those things. If we have a minimum on our graph, coming in from the left, our graph is first decreasing until we reach that minimum. And once we reach that minimum, it's increasing. It is the opposite when we have a maximum point. The graph is increasing until we reach the maximum, and then it is decreasing afterwards. Okay, another important feature of our parabola is the axis of symmetry. When our equation is in standard form, we just have to identify the parameters a and b and plug them into this little formula, which is x equals the opposite of b over 2 times a. Once we have that, we know that our axis of symmetry goes right through our vertex, so this x value is the x value of our vertex, which means I can take that x value and plug it into my function f to find the y value that goes with it. After we've done that, the easiest part is the y-intercept. It is simply just the point 0, comma, c, our constant at the end of our standard form. All right, let's first see how we can change from vertex form to standard form. I just want you guys to see an example because if you ever want to switch, it's not that difficult. All we have to use is algebra. In this case, I took the function that we graphed earlier today so we could compare our axis of symmetry and vertex with what we got earlier. Okay, so all I need to do to change to standard form is to simplify it out using multiplication addition. The f of x stays on the left. That is just what our function is. The first thing I'm going to do is rewrite this x plus 3 quantity squared as x plus 3 times x plus 3, because that's what we're doing when we square something. We're multiplying it by itself. Now I'm actually going to multiply those together by distributing. X times x is x squared. X times 3 is 3x. Then 3 times x is another 3x, and 3 times 3 is 9. That's all in parentheses, and I still have the plus 4 at the end. Now, looking inside these parentheses, I can combine like terms, which 3x plus 3x is 6x, and just write that differently. Now I'm going to distribute my 2 into the parentheses, so that'll be 2x squared plus 12x plus 18, and then I still have that plus 4 hanging out at the end. And finally, I can add that 4 on because I have no more parentheses. So my final function in standard form is f of x equals 2x squared plus 12x plus 22. Okay, so let's first start with the axis of symmetry. So in order to do this, we have to identify our values of a, b, and c. A is our first coefficient, 2. B is the coefficient of the x term, 12. C is your constant term, 22. So the axis of symmetry is x equals negative b, so 12 over 2 times a, 2 times 2. And we just do this math. This would be negative 12 over 4. 12 divided by 4 is 3, so we get negative 3. So we know our axis of symmetry is x equals negative 3. And you always need to write x equals because it is a vertical line. Now, to find the vertex, we plug that x value into the function. Okay, so we're finding f of negative 3. Plugging negative 3 in for all the x values. So I have 2 times negative 3 squared plus 12 times negative 3 plus 22. And simply following the order of operations, I should square negative 3 first, and I get a positive 9. If I multiply 12 times negative 3, I get a negative 36, and I still have plus 22 at the end. This is 18, 2 times 9. Negative 36 plus 22 is a negative 14, and 18 minus 14 is 4. So that means that my vertex is negative 3, positive 4, which makes sense, right? If we look back at our vertex form, wouldn't that be my h and my k value? Finally, our y-intercept is just the ordered pair 0, c, and c is 22. So our y-intercept is 0, 22. All right, I'm going to do the next example in the next video.